So today, we're going to break down an absolute masterclass in mobile engineering, how Dropbox completely rewrote their camera uploads feature. Seriously, this is the perfect real-world case study to help you crush your next mobile system design interview. So let's get right into it and start where every good interview begins, with the core problem.
Okay, picture this. You're in the interview, and they hit you with this question. I mean, that's a massive task, right? You got to think about reliability, performance, and doing it all at a huge scale for a feature that a company's most passionate users rely on every single day. Well, Dropbox faced this exact challenge, and how they solved it is just a goldmine of lessons for us.
We're going to tackle this just like you would in an interview. First up, we'll clearly define the challenge they were up against. Then, we'll dive deep into their new design. After that, we'll look at how they actually shipped the thing. And finally, we'll wrap it all up with the key takeaways you can use.
Let's start with the why. In any system design interview, your first step is always to understand the problems with what's already there. Dropbox wasn't building from zero. They had a feature that kind of worked, but it was old, creaky, and causing a ton of headaches for their engineers.
So first off, what is camera uploads? It's that bit of magic that automatically zaps your photos from your phone right into the cloud. And for Dropbox, the people using this are their best, most engaged customers. They expect it to be flawless and fast. The stakes? Yeah, they couldn't be higher.
And this slide, wow, it just lays out the core problem perfectly. The old system was this one big shared C++ library for both Android and iOS. Now that might sound efficient, but in reality, it had become this tangled web of platform-specific hacks. It was terrifying to make changes to. It had no idea how to handle modern background limits on phones, and it was a total nightmare to fix when things went wrong. A new, native approach for each platform, Kotlin for Android, Swift for iOS, was the only real solution. This is how you justify a major rewrite in an interview.
All right, so we've defined the problem. Now let's get into the fun part, the core design. Any solid system design answer has to focus on the most important requirements. For Dropbox, it really all boiled down to two things, and you'll hear this a lot in interviews: reliability and performance.
You see, the whole promise of camera uploads is that it just works, quietly, in the background. The idea is that even if you don't open the Dropbox app for weeks, your photos are still getting backed up safely. But, and this is a big but, modern mobile operating systems make this incredibly hard to do. So, how do you deal with an OS that might only give your app a tiny 10-minute window to do its thing? Simple. You use the tools the OS gives you. The team leaned heavily on Android's Work Manager. Think of it like a really smart scheduler. You just tell the OS, hey, I've got a bunch of photos to upload, do it for me whenever you get a chance and the network is available. This guarantees that when that precious window opens up, your app is ready to go. It's all about working with the OS, not fighting against it.
And this right here, it's a brilliant look at their actual upload process. It's a classic, super robust pattern. You take a big file, break it into smaller, 4-megabyte chunks. Each one of those chunks is then hashed and uploaded all by itself. And only when every single piece is safely on the server does the app send one final message to put the file back together. This makes the whole thing resumable and so much more reliable, especially on a spotty Wi-Fi connection.
The old system was kind of dumb about this. If an upload failed, it would just hammer away, retrying over and over, killing your battery and wasting your data. The new system is way smarter. It uses what's called exponential backoff, basically waiting a little bit longer between each retry. And it's smart about why it failed. If it's just a temporary network hiccup, sure, it'll try again. But if it's a permanent error, like the file is corrupt, it just stops. That saves resources and keeps users from getting annoying errors.
Okay, so reliability is table stakes. It has to work. But what users actually feel is performance. Nobody wants to sit around waiting for their photos to upload. So the next big question is, how do you make it fast without crashing the phone?
And boy, did the results speak for themselves. A 4-time speed improvement for big photo libraries? That is a massive, massive win. It's a huge upgrade to the user experience and the kind of metric that just screams, this rewrite was worth it. But getting there, that brought on a whole new set of challenges.
The obvious path to more speed is to upload a bunch of files at the same time, in parallel. But as soon as they turned that on, early testers started seeing a spike in out-of-memory crashes. And this is a classic engineering trade-off you'll always face: speed versus stability.
Okay, now this is the kind of nitty-gritty, deep technical problem-solving that interviewers absolutely love to see.
They didn't just give up on parallel uploads. No, they got clever. First, the app dynamically changes how many files it uploads at once based on how much free memory the phone has. Second, they used a special kind of memory buffer to get more direct control and avoid some weird Java caching issues. And third, they just reused one single chunk of memory over and over for all the file reads. This kept the system's garbage collector from working too hard and slowing everything down. Just brilliant engineering.
All right, so having a great design on paper is one thing, but shipping it to millions of people without, setting everything on fire, that's a whole different ballgame. Let's talk about the execution, which is just as critical as the design itself.
Okay, this part is just so smart. To make the rollout safer, they ran the new code silently in the background right alongside the old code, just comparing the results. And get this, with the hash validation, not only did they prove their new code was perfect, they actually found and fixed a super rare, long-standing bug in the old C++ code. And with state validation, they basically built a rulebook for how the uploader should behave, which caught a nasty bug that was causing extra unnecessary uploads.
And they didn't just, flip a switch and hope for the best. The rollout was this careful, phased process that took months. They started with a small group of beta users they could get feedback from. They watched their metrics like a hawk. And only when the data screamed, "This is stable," did they start rolling it out to everyone else. Because they were so careful, they actually finished ahead of schedule.
So after all that work, was it worth it? And maybe more importantly for you, what are the big lessons you can pull from this and use in your own system design thinking?
You can see it right here in the data. The story is crystal clear. After the rewrite went live, users started seeing far fewer of those frustrating waiting or error statuses and a whole lot more of that satisfying all done message. This is a real, measurable improvement to the user experience that proves the project was a huge success.
Okay, so if you're going to remember anything for your next interview, let it be these 4 key takeaways. 1, define your goals up front with clear metrics. 2, figure out the scariest parts of your design and de-risk them early. 3, don't rush the release. Start small and let the data tell you when it's time to go bigger. And 4, be ruthless with your scope. Just ship the core fix first. You can always add the fancy stuff later.
And that brings us to one last question to chew on. This whole Dropbox story shows how speed, reliability, and maintainability are all tangled together. They delivered on speed and reliability for sure, but the whole reason they started this project was because the old system was just impossible to maintain. So if you had to pick just one to prioritize at the very beginning, which would it be? Something to think about.